Computers and computing are in the midst of a major transformation, but the precise meaning of the word compute in reference to microprocessor design is not always clearly understood. Compute in this sense refers to hardware acceleration, both GPU acceleration and GPGPU, short for General Purpose Computation and Graphics Processing Units. The phrase "to compute" describes processing tasks and activities traditionally performed using a CPU that are now being performed on a GPU. We say the GPU offloads the CPU, freeing the CPU for other tasks. But why would we do this? CPUs are optimized for processing serial workloads, executing tasks in sequential order. In contrast, GPUs excel at processing parallel workloads, executing multiple tasks simultaneously. Until now, programmers forced a serial processing CPU to handle parallel processing application workloads, but with less than optimal results, including lower performance and higher power consumption. A heterogeneous processor combines different types of processors on a single piece of silicon, a good example being an APU that combines a GPU and a CPU on a single chip. The physical integration within an APU enables manufacturers to create much smaller, cheaper, and power-saving devices, especially since an APU's integrated on-chip communications consume far less power than two separate chips. Fully merging these once separate logic blocks on a single piece of silicon also requires shared access to data, and for the integrated processors to be treated as equals by the application. HSA, or Heterogeneous System Architecture, is an APU processor design that enables the CPU and GPU to work in harmony and allows equal access to memory resources. CPU resources are more than adequate for most traditional scalar workloads, but CPUs still struggle when used to analyze images, sort through vast databases, or do massive math calculations. Let's use Libre Office Calc as a good example. HSA is all about delivering new and enhanced user experiences through computing architecture advances that deliver improvements across three key vectors: better power efficiency, increased performance, and broad portability across computing devices. Another key advantage of HSA-enabled APUs emerges when confronting the parallel processing and visualization demands of today's big data computing environment, where massive and complex data sets overtax the capabilities of traditional CPUs and commonly used database tools. In less than 6 months, more than a dozen of the industry's elite have pledged their support to driving forward the new HSA standard. The rapid adoption of HSA will help usher in the next era of performance efficiency and dramatically improved cloud-based data management, streaming, and security.